Picking up where we left off, we're down here on number 17, and it was a doozy of a problem. Okay, so there's number 17. If I can get my scroll to work right, there we go. There's number 17. And I look at that and I was like, golly, I don't know any way to do that one. Common knowledge, or common sense, not common knowledge, it's not common at all, we just learned it, it's difficult to do. Common sense says, okay, let me get rid of those fractions first. That's a perfectly fine way to do this, okay? You can get rid of the fractions first, and then you can run some elimination, maybe some graphing, whatever you'd like to on it. But I look and I see, man, this y is already almost by itself, and if I can get y equals and y equals something, I can graph it. Well, the top equation is not going to be hard to do that with. I'm just going to divide by 6. This equation is not going to be bad to do it with either because I can subtract this 7/2 x to both sides. Just because it's 7/2 doesn't mean you can't move it to the other side the same way it would be if this was just a regular number, whole number here. So if I subtract 7/2 x from both sides, those are going to cancel out, and I'm going to get that y equals negative 7/2 x minus 4. Okay? That's one of my y equals done. I can graph that if I want. But I also know I need to do that with the second equation. My second equation was 6y equals negative 24 minus 21x. And the only thing to do to get y by itself here is divide by 6 and divide by 6. Those are going to cancel. I get y equals, this goes in evenly to be a negative 4. And right here, it doesn't go in evenly. It's gonna simplify. It would be 21 over 6 negative. And I know that 3 goes into both of them, so it's going to be 7/2, negative 7/2. Okay? So minus 7/2 x. And again, I'm looking like, oh, wow, wait a second. This is weird. These two equations look really, really similar. That's okay. We can go ahead and graph both of them and see what happens. We've got negative, and remember, yours graphs these a little bit nicer than mine. You can actually do fraction bars. Mine looks a little bit uglier. This red equation is negative 7/2, 7 divided by 2. Close that off. X. So yours will actually look like a fraction. Mine doesn't. This is the older version of the calculator. Minus 4. My bottom equation is negative 4 minus 7 divided by 2 x. I run zoom 6 on that. There's my first line. And then my second one never appeared. And this is where it gets a little bit tricky with these because I never got a second line. It's because these are the exact same equation. Therefore, they're the same line. And we have an infinite number of solutions. Now, one of the reasons graphing can be a super, super easy way to do these problems is because I knew how to do this simplification of this big, massive fraction, okay? But if you didn't know how to do that for that second equation, you can actually type it in, especially with yours doing the fractions a lot nicer than mine. You can type this in just like a big fraction and it'll graph it for you. For mine, I've got to use some extra parentheses for that. Negative 24 minus 21x on the top. And I'm going to divide that by 6. So yours will look like one giant fraction. Mine doesn't. But I can zoom 6 that. And there's my first line. And again, my second line's never going to appear because they're the same exact line. Don't get tripped up tomorrow and think, oh, I didn't get my second line. I misgraphed it. You might have. But there's also a chance that it's an infinite number of solutions because it's the same exact line. Okay? Number 18 is a very cut and dry graphing problem. We've already got y equals stuff and y equals some stuff. These are both already in slope-intercept form. So I can just graph both of these and find the intersection. Okay? I clear out whatever else was in there. I have x plus 4. And I have negative 6x plus 11. This is the kind of problem that gets a lot of kids into trouble on these tests because they've been going down through this big long section and they're getting discouraged because maybe they're not sure on a couple of their answers and they're just zooming through it, not happy, and they don't realize how easy this problem can be done. When I zoom 6 this, I see 2 lines come in, and as long as I can see the intersection point, and I can calculate it. If not, you have to zoom. So second trace, and number 5 is intersect. Enter, 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 and my intersection is 1, 5. Okay? With number 19, we get back to these word problems, and this time it's not set up for us, so you have to do some of the extra work. Define 2 variables, set up 2 equations, solve and answer. 3 different parts of these big questions here, okay? So I'm looking, and I'm talking about school A and B, so a lot of people are tempted to go with A and B. I wouldn't, as their variables. We're really talking about that they filled 8 vans and 7 buses, and it was 310 students. 4 vans, 8 buses, 272 students. So a lot of people on this one have an easy time figuring out what our equations are. They come from those 2 big chunks of information. However, to name our variables, we need to know what they're actually asking about. They're asking about vans and buses. So my V is for number of students in a van. And my B is the same thing, but with a bus. Okay? So when I go to set up these equations, I'm using this first big chunk of information, and I'll do that one in red. It's 8V plus 7B equals 310. In blue, I'll do the second big chunk of information, which is 4 vans, so 4V, and 8 buses, or plus 8B, carried 272 students. Notice how I say all these things in words, and yet I'm writing it out in math. Okay, that's why we use all these equations. They're a much easier way to express things. Well, now I take a step back, I look and I say, okay, I've got to solve this. What kind of method am I going to use? Well, when things are already lined up nicely for us, elimination tends to strike most people. I know I can change this 4 into a -8 by multiplying by -2. You could also tackle the 7 and the 8 and cancel those out, but you'd have to turn both into like 56, and you start multiplying by bigger numbers, it gets a little bit iffy. Okay? So I multiply here, I get a -8V, which I should so that it cancels, a -16B, and a -544. That's calculator work. Let's double check me, okay? -2 times 272, -544. Put that away. Now I'm ready to run elimination. Top equation, bottom equation. These are going to cancel out. I'm going to get a -9B equals, once again, calculator work right here. Okay? Should be a -234. Let's check me. Plus 310. -234. Plus, perfect. Divide by -9, divide by -9, and I find that B equals, I believe it was 26. 26 indeed. Okay? What do I do with that? Well, I've got to plug it back into an original equation. Either one of these 2 equations you created would work. I'll use the second one. It looks like it's got a little bit of easier numbers. 4V plus 8B, but we know B is 26, equals 272. 4V plus, once again, more calculator work. Last number I entered was 26, so if I just do times 8, it'll do that last answer times 8. That's what I've been doing this whole time. And we get 208. Subtract 208 from both sides. I get that 4V is going to equal 64. Divide by 4, divide by 4, and I get that V equals 16. That's all the math. Now you just have to express it in a full sentence. You would say something along the lines of a bus can hold 26 students and a van can hold 16 students. Seems kind of like a small bus and a big van to me, but the math checks out.